finding another Earth or something that is as similar as we can to what we see around us now.
What if the closest exoplanet to Earth, once thought to be our potential second home, turned out to be a cosmic disaster? Proxima B, orbiting the nearest star to our solar system, captured our imagination with the possibility of life. The James Webb Space Telescope has delivered revelations that are anything but comforting. Could this Earth-like planet be hiding a shocking truth? And what do these findings mean for our understanding of the universe? Once a symbol of hope for interstellar exploration, Proxima's tale has become one of shattered dreams and unsettling discoveries. Its brutal conditions and mysterious past challenge everything we thought we knew about habitable worlds. Are we close to uncovering a cosmic nightmare? Or does Proxima B hold answers humanity is not ready to face? Get ready as we walk through Proxima's mysteries, as we explore the truth, waiting just 4.224 light-years away. The discovery that shook astronomy. The year was 2016, and astronomers were on the edge of their seats. The European Southern Observatory, ESO, had just announced a discovery. Proxima B, a planet orbiting Proxima Centauri, the closest star to our solar system. This exoplanet, located just 4.24 light-years away, quickly became the focal point of excitement, speculation, and hope for humanity's search for life beyond Earth. For decades, scientists had wondered if we were alone in the universe, and Proxima B seemed like it could provide a clue to that age-old question. Proxima Centauri is part of the Alpha Centauri star system, a trio of stars that have fascinated astronomers for centuries. However, what set Proxima Centauri apart was its proximity and its classification as a red dwarf star. Red dwarfs are cooler and smaller than stars like our Sun, but they are also far more common, making up about 70% of all stars in the Milky Way. The discovery of a potentially habitable planet around such a star suggested that Earth-like planets might be far more abundant than previously imagined. Proxima B was detected using the radial velocity method, a technique that measures the tiny wobble a star experiences due to the gravitational pull of an orbiting planet. This method does not provide direct images of the planet, but it offers precise measurements of its mass, orbit, and distance from its star. Proxima B was found to have a minimum mass of 1.17 times that of Earth, placing it firmly in the category of rocky planets. What made Proxima B even more fascinating was its location in the habitable zone of its star. The habitable zone, often referred to as the Goldilocks zone, is the region around a star where conditions might allow for liquid water to exist on a planet's surface. Proxima's orbit is incredibly tight, taking just 11.2 Earth days to complete a revolution around its star. However, because Proxima Centauri is much cooler and dimmer than the Sun, this proximity does not necessarily rule out habitability. At first glance, Proxima B seemed like the perfect candidate for a second Earth. Its size, rocky composition, and position in the habitable zone all aligned with what scientists were searching for. The discovery was praised as a milestone, igniting hopes that life, or at least the conditions for life, might exist just beyond our solar system. However, questions quickly arose. Red dwarfs are notorious for their intense stellar activity, including powerful flares that can strip away planetary atmospheres. Proxima Centauri is no exception. Its frequent outbursts raised concerns about the stability of Proxima's environment. Would the planet have an atmosphere capable of shielding it from radiation? Could liquid water persist under such conditions? The discovery of Proxima B was undeniably monumental, but it marked the beginning of a much more complicated story. It set the stage for years of scientific inquiry, debates, and technological advancements, culminating in the James Webb Space Telescope's groundbreaking observations. Proxima B remains a symbol of both the potential and the challenges of exploring worlds beyond our own. To truly understand Proxima B's potential for habitability, we needed a closer look, and that's where the James Webb Space Telescope comes in. The role of the James Webb Telescope. When the James Webb Space Telescope launched in December 2021, it was seen as the most ambitious astronomical project in human history. Dubbed the successor to the Hubble, JWST promised to unlock the mysteries of the cosmos with unparalleled precision. While its primary mission includes studying the universe's first galaxies, Webb's unique capabilities have proven crucial in exploring closer and equally captivating targets, like Proxima B. What sets JWST apart is its suite of cutting-edge infrared instruments. Unlike Hubble, which operates mainly in visible and ultraviolet wavelengths, Webb's infrared vision allows it to peer through cosmic dust and study the faint heat signatures of distant objects. This makes it ideal for analyzing exoplanets like Proxima B, whose atmospheres and surface conditions emit infrared signals that can reveal vital clues about their habitability or lack thereof. The JWST does not just see planets, it listens to them. Its ability to perform spectroscopy is revolutionary. By capturing the starlight passing through a planet's atmosphere or reflecting off its surface, JWST can accurately identify that atmosphere's chemical composition. For Proxima B, this meant a chance to detect critical signs of habitability, such as water vapor, oxygen, or even methane, which could hint at biological activity. When JWST turned its gaze to Proxima B, scientists were eager to find answers to lingering questions about the planet's environment. Could it retain an atmosphere despite the violent flares of Proxima Centauri? Were there any signs of water or greenhouse gases that could stabilize its temperature? However, the data it delivered painted a bleak picture. Proxima Centauri, a red dwarf star, is famously unpredictable, emitting powerful stellar flares that bombard nearby planets with radiation. JWST's observations confirmed that Proxima B is subjected to these intense flares at a rate far exceeding what Earth experiences. More alarmingly, spectroscopy revealed no significant atmospheric signatures, suggesting that the planet's atmosphere, if it ever had one, was likely stripped away by its host star's radiation. This is a nightmare scenario for habitability because, without an atmosphere, Proxima B has no shield against cosmic and ultraviolet radiation, making its surface a barren wasteland. JWST's findings have essentially rewritten the criteria for exoplanet habitability. It is not enough for a planet to sit in the so-called habitable zone. The host star's behavior, the planet's magnetic field, and its ability to retain an atmosphere are now seen as equally critical. Proxima B, despite its promising location, fails these tests catastrophically. Yet Webb's role goes beyond delivering bad news. Its observations provide invaluable insights into the dynamics of exoplanets around red dwarf stars, which make up the majority of stars in our galaxy. By studying Proxima B, scientists are learning how to refine their search for habitable worlds, ensuring that future targets are more promising. In the grander scheme, the James Webb Telescope is proving that exploration is not just about finding answers, it is about asking better questions. Proxima's harsh reality underscores the importance of tools like JWST, which continue to push the boundaries of what we know and what we can hope to discover. As the James Webb Space Telescope peered deeper into the mysteries of Proxima B, scientists began to realize that the planet's true nature was far more complex than previously imagined. The search for habitable worlds isn't just about finding planets in the habitable zone, it's about understanding the forces at play in their environments. The atmosphere that never stood a chance. When scientists first identified Proxima B, many dared to dream of its potential to harbor life. That said, dreams can be deceptive, especially when a planet's star is a cosmic bully. Proxima Centauri, the red dwarf hosting Proxima B, is far from the gentle, nurturing star we call the Sun. Instead, it is a relentless, radiation-spewing monster that has likely destroyed any chance of an atmosphere in this rocky world. Let us start with the basics. An atmosphere is a planet's lifeline. It is the invisible armor that protects the surface from deadly cosmic rays, stabilizes temperatures, and, in Earth's case, provides the oxygen we breathe. Without an atmosphere, a planet becomes a barren wasteland, its surface scorched by ultraviolet radiation and its water vaporized into space. Unfortunately for Proxima B, it is caught in an interstellar no-man's land, where maintaining an atmosphere is practically impossible. Proxima's proximity to its star is both a blessing and a curse. While its position in the habitable zone suggests it could theoretically host liquid water, the reality is far more brutal. The planet orbits just 0.05 astronomical units, AU, away from Proxima Centauri, about 1/10 the distance of Mercury from the Sun. At such close quarters, Proxima B is subjected to stellar winds 2,000 times stronger than those experienced by Earth. These powerful winds act like a cosmic sandblaster, stripping away atmospheric particles layer by layer. Proxima Centauri's status as a red dwarf compounds the issue. These stars are infamous for their frequent and violent flares, which unleash bursts of X-rays and ultraviolet radiation. In 2018, astronomers observed a flare from Proxima Centauri that increased the star's brightness by 14 times in mere seconds. Such flares would be catastrophic for Proxima B, bombarding its surface with energy that can break apart atmospheric molecules and accelerate their escape into space. JWST data confirmed that Proxima B shows no detectable signs of an atmosphere. Its surface is likely exposed to the vacuum of space, leaving it defenseless against radiation. This means that even if the planet had water billions of years ago, it would have evaporated long ago, leaving behind a dry, desolate landscape. Some might wonder, could Proxima B have started with a thicker atmosphere, like Venus or Titan, that resisted erosion? The answer lies in the planet's magnetic field, or lack of it. A strong magnetic field, like Earth's, can deflect stellar winds and protect a planet's atmosphere. Even so, Proxima's small size and close orbit suggest it may have lost its magnetic field early in its history, leaving its atmosphere exposed and vulnerable. The odds were stacked against Proxima B from the very beginning. Even if life had managed to emerge in some hidden corner of this world, the constant barrage of radiation and the absence of atmospheric protection would make survival nearly impossible. Proxima's story is a clear reminder that not all planets in the habitable zone are created equal. The term might sound promising, but as Proxima B proves, location alone is not enough. The environment around the planet, the star's activity, the planet's magnetic field, and its ability to retain an atmosphere can make or break its chances for habitability. Yet, despite its hostile conditions, Proxima B remains a fascinating target for exploration. It challenges us to rethink what makes a planet habitable and pushes the boundaries of what we consider possible. And who knows, beneath its radiation-battered surface, there might still be secrets waiting to be uncovered. Tidally locked, a planet of extremes. If Proxima B had a resume, one of its most defining traits would be its status as a tidally locked planet. While it may sound like an astrophysical buzzword, being tidally locked is no small detail. It is the cosmic equivalent of a personality trait, and for Proxima B, it makes life both fascinating and brutally unforgiving. Here is how it works. A tidally locked planet always shows the same face to its star, much like how the Moon always shows the same face to Earth. This occurs because the planet's rotation period matches its orbital period. On Proxima B, this means one side of the planet is perpetually bathed in starlight, while the other remains in eternal darkness. Sounds dramatic, doesn't it? That is because it is. Let us paint the picture. On the day side, temperatures could soar to unimaginable extremes under the constant bombardment of Proxima Centauri's energy. The star, already a volatile red dwarf, unleashes powerful stellar flares that fry the surface with ultraviolet and X-ray radiation. The ground? Likely a barren, molten wasteland where nothing survives. On the night side, it is a different nightmare. Freezing, shadowy, and cut off from the warmth of the star. Imagine the coldest places on Earth, but multiplied by cosmic proportions. The extreme contrast between the two hemispheres of Proxima B creates a fascinating dilemma for any theoretical life form. Would life cling to the scorching day side, endure the icy night side, or thrive in the narrow twilight zone, the band of perpetual dusk at the boundary between light and dark? This twilight zone, also called the Terminator line, is the only place where temperatures might stabilize enough for liquid water to exist. But there is more. Being tidally locked is not just about light and darkness. It fundamentally shapes the planet's atmosphere and weather. If Proxima B had an atmosphere, which, as we discussed, is unlikely, the temperature difference between the hemispheres would drive violent, hurricane-like winds that constantly whip across the Terminator line. These winds would act as a conveyor belt, redistributing heat and creating a chaotic climate. For scientists, this is a great source of research questions. For hypothetical inhabitants, it is a tough place to call home. Tidal locking is not unique to Proxima B. Many exoplanets in the habitable zones of red dwarf stars are likely tidally locked. This means that countless second Earths out there could share the same extreme conditions, forcing us to rethink how we define habitability. And then there is the question of magnetic fields. Without one, Proxima B is defenseless against the stellar winds and radiation that continuously hit its dayside. Over time, this could strip away any remaining atmosphere and scorch the surface, rendering even the twilight zone inhospitable. Proxima's tidal locking is not just a scientific curiosity, it is a cosmic reminder of how delicate the balance for habitability is. The extremes of light and dark, heat and cold, destruction and potential survival make this planet one of the most intriguing yet unforgiving worlds we have ever studied. While Proxima B may not be a paradise, its story serves as a lesson for humanity. In the universe, conditions can change in an instant, and extremes are more common than balance. Yet, even in these hostile environments, there is always the possibility of uncovering something extraordinary. Proxima B's position in the habitable zone initially sparked excitement. Could liquid water be hiding in this distant world? With violent flares and relentless radiation from its star, could Proxima B's waters have ever withstood the odds? The search for water, a shattered dream. Water. It is the ultimate goal of planetary exploration, the ultimate signpost for life as we know it. When astronomers turned their eyes toward Proxima B, they were not just looking for signs of habitability, they were looking for the one molecule that could change everything. Could this distant exoplanet have liquid water, the very elixir of life? The answer, it turns out, is as heartbreaking as it is fascinating. At first glance, Proxima's position in the habitable zone of its star system raised a glimmer of hope. Being in this so-called Goldilocks zone means the planet could, in theory, sustain liquid water on its surface. Not too hot, not too cold. Even so, that is where the optimism ends. The reality is far more complex, and the evidence gathered by the James Webb Telescope and earlier observations suggests that Proxima's dream of hosting water is a story of unfulfilled potential. Proxima's proximity to Proxima Centauri, its parent star, is both a blessing and a curse. While its close orbit places it in the habitable zone, it also exposes the planet to constant stellar radiation. Proxima Centauri, being a red dwarf star, emits flares that are hundreds of times more powerful than what Earth experiences. These flares strip away atmospheres and, with them, the possibility of liquid water. That said, let us not stop there. To have liquid water, a planet needs not just the right temperature, but also an atmosphere to keep that water from boiling away or freezing solid. Spectroscopic analysis from the James Webb Space Telescope has revealed that Proxima B shows no signs of an atmosphere capable of supporting liquid water. Without an atmospheric shield, any water that once existed on the surface would have long since evaporated into the void of space, carried away by the relentless stellar winds. Scientists believe Proxima B may have started its life with water. Early in its history, when Proxima Centauri was less active, the planet might have harbored vast oceans. However, over billions of years, the star's increasing activity likely stripped the planet of its protective atmosphere and boiled away its water reserves. What is left now is a barren, lifeless rock, a sobering reminder of how fragile the conditions for life can be. Adding salt to the wound, Proxima's tidal locking only worsens its chances. The planet's day side is scorched by constant starlight, while the night side is frozen in perpetual darkness. Even in the Terminator zone, the thin band between light and dark where conditions might be stable, it is unlikely that water could exist in liquid form without an atmosphere to regulate temperature and pressure. The search for water on Proxima B was never about finding an Earth twin. Instead, it was about understanding how planets evolve under extreme conditions. While Proxima's shattered dream of hosting water may seem like a dead end, it teaches us invaluable lessons about planetary habitability and the forces that shape alien worlds. In the grand cosmic story, Proxima B is a tragic figure, a planet that could have been a paradise but was undone by the very star that gave it life. And yet, its tale is not without hope. By studying Proxima B, we are learning how to refine our search for life elsewhere, ensuring that future discoveries will not just ignite hope, but fulfill it. But what if life could still find a way? What if, against all odds, there are survivors in the most extreme environments we can imagine? Proxima B might not be a lost cause. Its story could still be one of extraordinary adaptation. Could life adapt to such extremes? When it comes to life's adaptability, Earth's history is proof that nature is a master of survival. From microbes thriving in the scalding vents of the ocean floor to bacteria frozen in Antarctic ice, life has a way of defying the odds. Even so, could the most resilient organisms adapt to the nightmarish conditions of Proxima B? It is a question that tantalizes scientists and challenges our understanding of biology and survival. how about we start with the basics? Proxima B, as we have explored, is a planet of extremes. With its tidally locked orbit, one side endures relentless radiation while the other plunges into eternal darkness. The terminator zone, a thin region of perpetual twilight, seems like the only place life could even attempt to exist. Still, even there, conditions are far from hospitable. With no atmosphere to moderate temperatures, the boundary between light and dark would be a chaotic mix of scorching heat and frigid cold, whipped by powerful winds. For life to adapt here, it would need to be unlike anything we have ever encountered on Earth. Extremophiles, organisms that thrive in extreme environments, give us a glimpse into what might be possible. Take Deinococcus radiodurans, also known as Conan the bacterium. This tiny but mighty microbe can withstand radiation levels thousands of times higher than what would kill a human. If life on Proxima B exists, it might resemble such hardy microbes capable of surviving the intense radiation storms unleashed by Proxima Centauri. Still, radiation is not the only challenge. On Proxima's night side, temperatures would fall headlong below freezing, while the day side would be an uninhabitable inferno. Any life form here would need to either burrow deep underground, where temperatures are more stable, or find refuge in the terminator zone. Even then, it would have to endure the lack of liquid water and the absence of a protective atmosphere. Could life evolve to extract water directly from minerals, or survive without it altogether? Some extremophiles on Earth have shown it is possible, but the scale of adaptation required on Proxima B is almost unimaginable. What if life on Proxima B does not rely on water at all? Scientists have theorized that alien life forms might use solvents other than water, like ammonia or methane, to sustain themselves. Such organisms would be chemically distinct from anything we have ever seen, a true alien biology. While there is no evidence yet to suggest this on Proxima B, the idea expands the scope of what we consider habitable. Then, there is the possibility of subsurface life. On Earth, ecosystems exist miles beneath the surface, thriving in complete darkness and relying on chemical energy instead of sunlight. If Proxima B has a geologically active core, it might host hydrothermal vents or pockets of subsurface water, providing a potential haven for microbial life. This is where the James Webb Telescope's future observations could prove invaluable, offering clues about the planet's geology and potential for underground habitats. While Proxima's conditions seem almost impossibly harsh, life has surprised us before. If life has adapted to exist on this extreme exoplanet, it would represent a completely new branch of biology that challenges everything we know about survival and evolution. Even if Proxima B turns out to be lifeless, studying its environment will push us to expand our definition of habitability and look for life in places we would have never thought to search. In the end, the question is not just whether life could adapt to Proxima's extremes, it is whether we are ready to accept just how diverse and resilient life in the universe might be. The reality of alien life on Proxima B. The question of alien life has fascinated humanity for centuries. Could we be alone in this vast and mysterious universe? When Proxima B was discovered, it ignited a wave of hope, a potential Earth-like planet orbiting the nearest star to our solar system. But as scientists dig deeper into the realities of this distant world, the dream of extraterrestrial neighbors becomes murkier. So, let us explore what the James Webb Telescope and cutting-edge research tell us about the potential for alien life on Proxima B. First, we need to confront the elephant in the room. Proxima B is no utopia. Its harsh environment makes it one of the least likely places for life to flourish, at least life as we know it. With no significant atmosphere to protect it, the planet is constantly hit by deadly stellar radiation. This leaves its surface barren and exposed, making it inhospitable for complex life forms like plants or animals. Even if life did exist in its early days, Proxima Centauri's violent flares would have likely erased any chance of survival over billions of years. If alien life exists on Proxima B, it is probably microscopic. Single-celled organisms, like extremophiles on Earth, are the most credible candidates. These resilient microbes could potentially hide underground or in isolated pockets where they are shielded from radiation. While this does not sound like the alien civilizations we see in sci-fi movies, discovering microbial life on Proxima B would still be a big revelation. It would prove that life is not unique to Earth and might be more common in the universe than we thought. Nonetheless, let us not get ahead of ourselves. For life to exist, even at the microbial level, Proxima B would need stable sources of energy and a liquid medium, like water, to support biochemical reactions. As discussed earlier, water is unlikely to exist on the surface due to the planet's lack of atmosphere and extreme temperatures. However, subsurface environments could offer a ray of hope. If Proxima B has a molten core, geothermal energy might drive chemical reactions in underground pockets, much like Earth's deep-sea hydrothermal vents. Scientists are not just looking for life on Proxima B, they are also trying to understand the limits of habitability in the universe. Proxima B serves as a case study for how planets evolve under extreme conditions. By studying this world, researchers can refine their search criteria for more promising exoplanets. In a way, Proxima's challenges make it even more valuable to science. It forces us to think beyond the narrow confines of Earth-like conditions and imagine entirely new forms of life. And what about the possibility of intelligent life? While it is tempting to imagine advanced beings adapting to Proxima's extremes, the evidence simply is not there. The planet's lack of resources, atmosphere, and surface stability makes it highly unlikely that intelligent life has developed or survived. Still, the search for biosignatures and chemical markers of life continues. The James Webb Telescope is already pushing the boundaries of what we can detect, and future missions may uncover surprises we cannot yet predict. Even if Proxima B turns out to be lifeless, its story does not end there. This planet challenges our assumptions about life in the cosmos and forces us to confront the brutal realities of survival beyond Earth. It is a reminder that the universe is both awe-inspiring and unforgiving, but it is also a testament to humanity's relentless curiosity. By studying Proxima B, we are taking the first steps toward answering the ultimate question: are we alone? In the end, Proxima B might not host alien civilizations or lush ecosystems, but it still holds the key to understanding our place in the universe. Sometimes, the search for life is not just about finding others, it is about discovering what it means to be alive. But what if Proxima B holds more than just a harsh lesson? What if the key to unlocking the mystery of life beyond Earth lies in this unforgiving world? As the search continues, one thing is clear: the story of Proxima B is far from over. The next steps: mission to Proxima Centauri. The discovery of Proxima B is only the beginning. While the James Webb Telescope has provided invaluable insights, the next logical step is sending a dedicated mission to Proxima Centauri to uncover its secrets firsthand. But how do we bridge the daunting 4.24 light-years separating us from this enigmatic star system? The answer lies in the remarkable advances in space exploration currently taking shape. The Breakthrough Starshot Initiative, one of the most ambitious projects in human history, aims to send tiny, lightweight probes to Proxima Centauri at 20% of the speed of light. Equipped with sails powered by laser beams from Earth, these probes, called star chips, could reach the star in just 20 years. Once there, they would capture high-resolution images of Proxima B, analyze its atmosphere, if any, and look for signs of habitability or life. However, this is not just about technology. It is about redefining our place in the universe. Missions like Breakthrough Starshot are humanity's first attempts at interstellar travel, setting the stage for future generations to explore worlds beyond our solar system. And with every step forward, we inch closer to the ultimate goal, which is discovering whether we are truly alone. While robotic missions are the immediate focus, the dream of sending humans to Proxima Centauri is far from forgotten. Advances in propulsion systems, cryogenics, and artificial ecosystems could one day make interstellar colonization a reality. Proxima B, despite its challenges, might even serve as a stepping stone for exploring more distant worlds. In essence, the mission to Proxima Centauri is not just about answering scientific questions. It is about reigniting humanity's sense of wonder and ambition. As we gaze at the stars, we are reminded that the greatest adventures lie ahead, waiting for us to take the first bold steps. The James Webb Space Telescope has shown us that space exploration is as much about challenges as it is about discoveries. Proxima B may not be the paradise we hoped for, but it remains a critical piece in the puzzle of understanding our place in the universe. If this journey into the mysteries of Proxima B intrigued you, do not miss our next video, where we uncover new revelations from the James Webb Telescope.